All right. So, theorem 7.3, the altitude for the hypotenuse of a right triangle divides it into two triangles that are similar to the original triangle and each other. The altitude to the hypotenuse of a right triangle divides it into two triangles that are similar to the original triangle and each other. So, what that looks like visually, did I knock him out? No. Anybody?
No. You did two rows, I think.
Maybe why I told me what. I gave them out to you guys? Gave them out to you guys? Alright, so let's try this again. The altitude to the hypotenuse of a right triangle divides into the two triangles that are similar to the original triangle and each other. That are similar to the original triangle and each other. Now, this only works for right triangles. So basically, there's our right triangle. This is your hypotenuse, correct? Based upon definition of a right triangle. That is an altitude. By definition, the altitude of a triangle goes from a vertex and is perpendicular to the opposite side. So what you need in your sketch is you need two right angles. The biggest triangle on the outside needs to be a right triangle, and then you got to have right triangles in the middle. Now, here's where things visually get a little tricky, and these are my suggestions to you. I'm going to call that short leg. I'm going to call that long leg. I'm going to call that the hypotenuse. That is how I would tell you to look at these. Identify and recognize the shorter leg, the longer leg, and then the hypotenuse, because all of those are going to be proportional. It's the easiest way to set up your ratios, which allows you to do it. This is what I mean. In here, so if I go down here, to that sketch, ABC is the original triangle. AC is the short leg. BC is the long leg, and AB is my hypotenuse. What happens is we draw on the altitude. That's that segment, which divides it into two triangles, 1 and 2. You get where I'm at so far? So this is triangle 1, and this is triangle 2. There's my short leg. There's my long leg. There's my hypotenuse. There's my short leg. There's my long leg. There's my hypotenuse. That's how you can set up your ratios, which in turn give you your proportion to solve. The other thing you may want to keep in mind, if you struggle with figuring out which ones are set or which, do yourself a favor. Add numbers. Add numbers. Alright, add numbers. So in other words, and I'll bring that back in a second, I'm going to say that that angle is 70 degrees. That means this one is 20 degrees by angle sum of a triangle, correct? This one is 70 degrees. This one is 20 degrees, and it allows you to match up the congruent angles the same way. Okay? Make sense? So it'll work. All right, it'll work. All right. So, write a similarity statement relating the three triangles in each diagram. So, if I look at number 5, triangle RQT is similar to. Now, this is where putting in the numbers can help. If I look at triangle RQT and make that the 20 and that the 70, I now come and make that the 20, that the 70, and that allows me to go with the similarity statement for both. So if I look at RQT, I'm starting at R, which measures how many? 70. I'm going down to Q, which measures how much? 90. And then I'm ending at T, which gives me 20. So now I'm going to go to the smaller one. I want to go 70, 90, 20. So what order is that going to be? R, S, Q. So triangle RQT is similar to triangle RSQ. And now I'm going to do the same thing with the lower one. Again, 70, 90, 20 means Q, S, T. Okay? Does that make sense? So if you plug in numbers, it'll enable you to find the path. So whichever method you use, give number 6 a whirl. If, at first, when you look at it, it's hard to see which one is which angle, feel free to draw it differently. If that's going to be beneficial to you, you'll still get the same answer. And if I do that and I go triangle ABC, it's similar to triangle. So ABC looks to go 70, 90, 20. Triangle ADB, 70, 90, 20. Similar to triangle BDC. 70, 90, 20. Could your answer be correct and you have it in different orders? Absolutely. However, when you're done, you should have 2 letters that are the same, 2 letters that are the same, and 2 letters that are the same. So you should have 3 different spots where you have the same letter. Make sense? Good so far with that. All right, that leads us to a little math. All right, given numbers A and B. The geometric mean of A and B is the positive number X, such that X over A equals B over X. If you were to solve that, you would cross multiply. The result would be A times B equals X times X. What do we usually describe X times X as? X what? Squared. Good. And then if I were to solve for X, from last year, how do you solve an equation with a square root? What do you do to both sides? Square root. It's basically the square root of the product of the numbers. It's basically the square root of the product of the numbers. Alright? So if it says find the geometric mean of 6 and 15. Alright? The geometric mean of 6 times 15. There are two ways of going about it. Number one is do the multiplication. Anybody think they know what 6 times 15 is? 90. Does anybody happen to know the perfect square that goes into 90? It's right in it. Right in the front. 9. What is the square root of 9 that's coming outside that train? 3. And then the 10 stays on the inside for 3 root 10. Now, you don't have to do it this way, but there is another perspective. 6 breaks down into 3 times 2. 15 breaks down into 3 times 5. Again, don't have to do it this way, but you can. What number shows up twice? That's coming outside. What two numbers remain inside? 2 and 5. What is 2 times 5? You get the same answer. Make sense? Seem good? Alright, keeping that in mind, try number 11 and 12 on the top of the next page. 11 and 12 on the top of the next page. For 11, you get 2 root 42. For 12, you get 10 root 30. For number 10, because it's big, I would break down 500 into what? 5 times 100, because what? 100 is a what? Perfect square. That's going to come outside. Square root of 100 is 10. 6 times 5 is 30. We end up with 10 root 30. Everybody good with that idea? Now, the one that's tricky underneath it is number 14. Remember, the geometric mean is the square root of the product. So you would have the square root of the square root of 50 times the square root of 2. So you don't have one radical. How many radicals you got? 2. So the first thing you do is multiply 50 times 2. What is 50 times 2? 100. So that becomes the square root of the square root of 100. What is the square root of 100? 10, making it a perfect square, so you'd have the square root of 10. Alright? Everybody good? Now, how it relates to this figure. I'm going to call GJ the short leg of the triangle on the left. And I'm going to describe HJ or JH as the long leg. Does that make sense? So now I'm going to look at the one on the right. HJ is now the short leg of that one, and JK is the long leg. Make sense? So if I go short leg over long leg, which I'm allowed to do to set up my proportion, on the left that would be GJ over HJ, and the one on the right would be HJ over JK. You will notice what segment shows up both times. HJ, the altitude. So HJ squared equals GJ times JK, and then HJ is the square root of that product. All good? So we have ourselves a corollary. Corollary 1 is theorem 7.3. The length of the altitude, the length of the altitude to the hypotenuse of the right triangle is the geometric mean of the lengths of what we describe as the segments of the hypotenuse. Alright? So basically, this is the hypotenuse. Each one of those is segments. And unless it's an isosceles right triangle, those segments are going to be different. There's going to be one longer and one shorter. So A squared equals B times C. So A squared equals B times C. Seem good? Okay. So if I look on the right, or the next page, and this is most likely where we're going to end the day, use the figure at right to complete each proportion. So this just sets us up for what's to follow, which is to find values. D over C. So that's that length and that length. Alright, now I'm not worried about altitudes, I'm worried about short legs and long legs. D over C. D's the what of that triangle up top? Long or short? Long. C is what? Long or short? Short. So D over C would be long over short. Make sense? So now C's also got to be the long. So now I'm focusing on the other triangle where C's the long. And what's the short leg of that one? E. So D over C equals C over E. Alright, D over C equals C over E. When I look at 16, blank over B equals B over E. So now I'm focusing on this triangle. For the first time, B in that triangle is the what? Hypotenuse. So I got hypotenuse over E, which is the what? Short leg. So now I see B is the short leg here. Where B is the short leg, what is the hypotenuse of that triangle? F. Alright, try 17 real quick. Should take about a minute. F over blank equals blank over D. Couple things about this one. Number one, alright, one of them will be an isolated segment. So in other words, see how D can only be one thing? Not like C and other things. So D is the long leg. F is a what? Hypotenuse. So we have to figure out which one is the long leg where F is the hypotenuse, and that would be what? A. So now where D is the long leg, what is the hypotenuse? Ed, if you get one like that coming up, I promise you the letter will be exactly the same. And that's where we'll pick it up tomorrow. Alright? So if you can, try to get 7.3 done tonight. We'll go over it tomorrow. After Thursday, we're going to have a quiz. Unfortunately, probably Tuesday, the day after the 3-day break, because we got to get the test in by next Friday. I got to look at the calendar to confirm that, but that's what we're looking at.